Hello everyone, welcome to PG Chemistry channel. Today we are going to discuss continuation decomposition reaction. Previous video we discussed thermal decomposition. Today we are going to discuss electrolytic decomposition. Electrolytic decomposition. Electrolytic decomposition. Decomposition reactions based on energy total classified into three types: thermal decomposition, second one electrolytic decomposition, third one photolytic decomposition. So electrolytic decomposition definition how to write, already I said clearly in the previous video. A single substance split into two or more products by electrolytic decomposition, no, by passing current through it. Okay, so just at last for the same definition, if you mention by passing current, by passing current. Okay, now here this very important for 3 marks question. Last year also they asked, means present this year also they asked related to these questions. Here diagram is very important. See here diagram. Take a container. Container fixed with metal rods which will act as a electrodes. Okay. So that electrodes connect to the battery. Battery positive terminal, negative terminal. Okay. Battery negative terminal metal rod we used to call cathode. Battery negative terminal metal rod we used to call cathode. Opposite positive terminal we used to call anode. Anode means positive, cathode means negative. Now in electrolytic decomposition, we are going to decompose a chemical substance. Here we are using water to decompose. So the substance which you are going to decompose, that substance will be act as a electrolyte. Okay, the substance which you are going to decompose, that will be called as electrolyte. Here water act as a electrolyte. The substance water act as a electrolyte. But pure water is bad conductor now. We are using little acid to pass current into it. So that is we call acidified water. Acidified water. Acidified water act as a electrolyte. Now, why we are using acid to the water means pure water is bad conductor of electricity. So to make it decompose, current should enter into it. That is what we are using little 2 or 3 drops acid. Okay, or any salt. Little, but maximum cases we used to prefer acid only, either HCl or H2SO4. 2 to 3 drops, not maximum. Okay, now we are inverting test tubes over the electrodes, because in these gases are going to liberate. That gases we need to collect means we should use test tubes over the electrodes to collect. Now, what happening here? H2O. We are passing current through it. Okay, this H2O is acidified. We added acid also. Acidified water. Acidified water. Now, it will get decomposed into H2 plus O2. Balance it, 2H2 gives us to 2H2 plus. But here, questions, at which electrode, which gas liberating? At which electrode, which gas liberating? That is very, very important. Okay. Now, see here. This here they given same diagram. Just they mentioned X, Y, Z. They asked to find out in which test tube. Even they are not given battery, positive terminal which one, negative terminal which one. That is also they are not asked. Okay. So we have to find out based on the liberation of gas. See here, I will write once again equation. H2O gives rise to H2 plus O2. Balance it, 2 H2O gives rise to 2H2 plus O2. If you observe, compare to oxygen, here after decomposition, hydrogen 2 volumes, oxygen only 1 volume. So, hydrogen liberated more than oxygen. Why hydrogen is double the volume than oxygen means, as per its composition in H2O, hydrogen 2 volumes, oxygen 1 volume combined. So, same ratio will be liberated according to law of conservation of mass. Matter can neither be created nor destroyed. Okay. How much molecule combined? Same molecule will be again decomposed. Okay. So, hydrogen liberated at cathode. Hydrogen liberated at cathode. Oxygen liberated at anode. So, in cathode test tube, hydrogen gas liberated. That hydrogen gas, more volume of hydrogen. Just they given this diagram like this and ask question, which is cathode, which is anode. Oxygen liberated compared to hydrogen, oxygen less volume. No? This green appearance completely like a hydrogen gas. Hydrogen gas. Now, here, oxygen gas liberated. Oxygen gas liberated here. O2 gas. Okay. So, oxygen is one volume, hydrogen is more volume. That is what hydrogen appearing more quantity, oxygen appearing less quantity here. Because the equation, hydrogen 2 volumes, 2H2, oxygen only 1 volume. That is what the liberation of hydrogen and oxygen 2:1 ratio. Hydrogen is 2, oxygen is 1 ratio. 2:1 ratio. This is the water. Electrolytic decomposition of water. See here, question some they will ask. At which electron, which gas liberated? At cathode hydrogen, anode oxygen. Anode oxygen. Cathode hydrogen. Opposite. Okay. Anode oxygen. Cathode hydrogen. Next, what is the ratio of gases liberated? Hydrogen is 2:2, oxygen is 2:1 ratio. Why hydrogen is double than oxygen? Because hydrogen and oxygen, it's a composition in water 2:1, 2 hydrogens, 1 oxygen combined. So the same ratio will be liberated. Next, why we are preferring acid to the water? Because water is poor conductor of electricity or bad conductor, bad conductor only best. Okay, water is bad conductor of electricity. So to make it decompose, current should enter into the water. That is what we are using small amount of acid. At the time we used to call acidified water. Okay, these are the questions they used to ask. Like this diagram they given this here, gas they shown clearly, more volume, less volume. Based on that, we should come a reverse process. Okay, in this gas shown more volume is in water, more volume, which will be liberated hydrogen. Hydrogen liberated, where it will liberate? At cathode. So this is cathode. This is anode. Okay, so at cathode, cations moving towards cathode. Means H plus moving towards cathode, gaining electron. Gain of electrons are called reduction. Okay, so at cathode, reduction process is going on. At anode, oxidation process going on. The process at cathode and anode. At cathode, reduction process. This also they will ask. At cathode, what happening is reduction process happening. At anode, oxidation. Okay, this is complete information about electrolytic decomposition. Expected compulsory question. Yes, dear all, here one thing I am observing, whatever conceptual videos we cannot able to cut this like smart videos. That is what we should follow compulsory complete information in one shot. That is what it will take some extra time. That may be sometimes half an hour also, 40 minutes also. Only the very easy to cut the information, but I am not ready to cut it. So maximum information I am giving, but you should have patience to listen class. That will be useful to you. Okay. Thank you to all.